Welcome to our journey through the cosmos, where we'll explore some of the most dangerous places in the universe. We often gaze up at the night sky and feel a sense of awe and wonder. The twinkling stars, the distant galaxies, they beckon us to explore the vast unknown. But the universe is not always a friendly place. Today, we're going to shine a light on these cosmic danger zones, those corners of the universe that would spell disaster for anything that ventured too close.
Black holes. Just the name conjures up images of cosmic monsters lurking in the darkness, waiting to devour anything that crosses their path. They pretty much live up to their reputation. Imagine a place where gravity is so strong, so utterly dominant, that not even light, the fastest thing in the universe, can escape its grasp. That's the nature of a black hole. They're formed from the remnants of massive stars that have collapsed in on themselves, creating a region of space-time so warped it's effectively cut off from the rest of the universe. Now let's say you were to take a spaceship and get a little too close to a black hole, ignoring all those flashing red warning signs, of course. What would happen? Well, you'd experience the ultimate cosmic makeover, spaghettification. As you approach the black hole, feet first, the gravitational pull on your feet would be significantly stronger than on your head. This difference in gravity, what we call tidal forces, would stretch you out like cosmic spaghetti. Not a pleasant way to go, right? But it gets weirder. As you're being stretched and pulled towards the black hole's point of no return, the event horizon, time itself, would begin to warp around you. From your perspective, time would seem to slow down, while for someone watching from a safe distance, you'd appear to freeze, your image forever frozen on the event horizon. Eventually, you'd be pulled past the event horizon, crushed into oblivion, added to the ever-growing mass of the black hole. But black holes aren't just cosmic vacuum cleaners. They play a crucial role in the evolution of galaxies, influencing the formation of stars and shaping the very fabric of space-time. Now, if black holes are the universe's heavyweights, then gamma-ray bursts are its lightning strikes, sudden, incredibly powerful, and capable of causing unimaginable destruction. Imagine this. In a fraction of a second, a single burst of gamma rays releases more energy than our sun will emit over its entire 10 billion year lifespan. That, my friends, is the raw, untamed power of a gamma ray burst. These cosmic explosions are thought to be the result of the most cataclysmic events in the universe. The death throes of massive stars collapsing into black holes, or the collision of two neutron stars, those ultra-dense remnants of stellar explosions. Now, the good news is that gamma-ray bursts are incredibly rare and occur at vast distances from us. But what if, hypothetically, one were to occur in our cosmic neighborhood, say a few thousand light years away? Well, let's just say it wouldn't be pretty. If a gamma-ray burst were to hit Earth directly, it would be like aiming a cosmic death ray at our planet. The intense radiation would strip away our atmosphere in seconds, leaving us exposed to the vacuum of space. But even though they pose a potential threat, gamma-ray bursts are also a fascinating window into the most extreme environments in the universe. If black holes are the ultimate crushers, then neutron stars are the universe's ultimate magnets. These bizarre objects are the remnants of massive stars that have gone supernova, their cores collapsing under their own gravity to form objects so dense that a teaspoonful would weigh billions of tons. Now imagine cramming the entire mass of our Sun, about 333,000 times the mass of Earth, into a sphere just a few miles across. That's the kind of density we're talking about here. But it's not just their density that makes neutron stars so dangerous. They also possess the strongest magnetic fields in the universe, trillions of times stronger than Earth's magnetic field. These magnetic fields are so powerful that they can distort the very fabric of space-time, creating intense beams of radiation that sweep across the cosmos like cosmic lighthouses. Now, let's say you were foolish enough to get too close to a neutron star. What would happen? Well, first, the intense gravity would rip you apart atom by atom. Then your atoms would be subjected to the star's incredibly strong magnetic fields, stretching and compressing them into bizarre shapes. And if that wasn't enough, the intense radiation emanating from the star would fry you to a crisp. We've talked about the dangers of black holes, gamma-ray bursts and neutron stars, but the universe has another trick up its sleeve, and the explosive aftermath of a star's death throes, supernova remnants. Imagine a star many times larger than our Sun reaching the end of its life. It's used up all its fuel and its core collapses under its own gravity, triggering a runaway nuclear reaction that rips the star apart in a brilliant explosion that can outshine an entire galaxy, a supernova. Now, while the initial explosion is certainly a sight to behold, it's the aftermath that poses a lingering threat. What's left behind is a swirling cloud of gas and dust, the supernova remnant, expanding outwards at thousands of kilometers per second. This expanding cloud is not just some harmless cosmic dust bunny. It's laced with heavy elements forged in the heart of the dying star, including radioactive isotopes that emit deadly radiation. Any planet caught in the path of this expanding cloud of debris would be bombarded with intense radiation, potentially stripping away its atmosphere and rendering it uninhabitable. But supernova remnants aren't just agents of destruction. We often think of planets as being anchored to their stars, orbiting in predictable paths. But what about planets that have been flung out of their star systems, cast adrift in the vast emptiness of space? These are rogue planets, cosmic nomads wandering the interstellar void. Now, you might think that a planet without a star wouldn't be particularly dangerous. After all, it's not like there's a sun to fry you or a black hole to tear you apart. But rogue planets present their own unique set of challenges, making them some of the most inhospitable places in the universe. First and foremost, rogue planets are cold, incredibly cold. Without a star to provide warmth, temperatures on these planets plummet to near absolute zero, cold enough to freeze even the most resilient of life forms. But it's not just the cold you have to worry about. Rogue planets are also shrouded in perpetual darkness, making navigation nearly impossible. And without a star to provide a gravitational anchor, they're free to wander aimlessly through the cosmos, potentially colliding with other planets, stars, or even black holes. But perhaps the most unsettling aspect of rogue planets is their sheer isolation.
Thanks for joining us on this cosmic adventure. Stay curious and keep exploring the wonders of the universe. We've journeyed to the edges of the universe, explored the most extreme environments imaginable, and stared into the face of cosmic danger. But through it all, one thing remains clear. The universe is a place of wonder, mystery, and endless possibilities. Keep asking questions, keep seeking answers, and never lose your sense of wonder.